Hello everyone, welcome back to another Inventive tutorial. My name is Mr. Galindo and we are close to completing the computer-aided manufacturing stage of our F1 in Schools program. Now, so far we've created a setup, oriented and gotten a vehicle into an assembly that we're going to manufacture with fixtures and stock. The next thing we're going to do is actually do something called a CAM cycle or a program. Basically, there are these set up cycles or systems or programs that you can apply to your CAM setup. And what they do is they then ask the tool or tell the tool or guide the tool to follow a certain path, which will then have an outcome. So this would be how you would face some material or manufacture or cut away some material to a certain shape. There's different types of cycles. It gets quite complex. We're going to just cover what we need to use in this particular tutorial. Now, the first one we always do with our F1 in Schools vehicles is a drilling cycle, and the drilling cycle allows us to drill the holes, and it basically moves the cutter along to the right point and then straight down, and then quite quickly it comes back out again because it doesn't want to sit there spinning in case it burns the material. So all I've done there is I've selected drill, and as I've been talking I selected the two axle holes because that's what we needed to drill out. Then I'm going to go to the clearance height. I'm going to select this to be 2.5, and the bottom height you need to make sure you select the origin and then -4. The reason for this is if the clearance retraction height is too high, our CNC can't go that high. 10 mils means it's about 57 or so, and it just gets stuck. It can't go that high, and it throws error codes at us. The bottom height, we don't go below this because the drill bit, if it goes much further than the actual fixture, the bit that what we call a holder that holds that drill bit in place, so it kind of like it's a clamp and it holds it in place, that would then hit our vehicle and damage it. So again, we don't want to go too far. So we go -4 just to make sure we go over halfway, and also then remove any fillets from the 3mm fillet radius of our cutter. Make sure you select the right cutter, everyone. So we've got one tool that we use basically for the class subjects of F1 in Schools, and it's a 6mm ball nose, which you need to select and customize for the first time in your computer. It may already be there because another student has done so, but that just means you need to check that they've done it correctly, because if they haven't and you use it, it will not work at all. So to start with, we select under all tools, we go by type, which I click the plus, find the ball mill folder, scroll down until you find 6mm, and once you get to the 6mm diameter ball mills, you'll notice that there's maybe an F1 or an F1 cutter like mine is. I'd like you to use this, but you need to right click on it and go edit, just in case it is not quite correct. So I've gone edit on this F1 cutter, and I'm going to select cutter under here, make sure it says F1 cutter, and I'm going to make sure it says ball mill. The diameter is 6mm as we know, and the shaft diameter is also 6mm. The shoulder length is 50, and the flute length, which is the cutting edge of the bit, so the sharp edge, is 48. In fact, give me 1 second and I'll go get one to show you. Wasn't that quick? The wonders of video editing. I have here in my hand one of the bits that we use. This is a 6mm ball mill, and you can see that it's got two sharp edges that go along the front end there, and then they turn into a spiral pattern that is very, very sharp along the edges, but only up to about this point. So on your cutter page, on your for editing your bit, you need to make sure the flute length is about 48, as is the actual one. The shoulder is 50. The shaft and the diameter is 6mm because it doesn't change, if you can see that. The overall length is about 75mm. Having done that, we want to make sure the holder is correct. So the BT30 blank is the correct holder. If you don't have that one, you can select the option there, go to all tools and holders, and it's the top one. It's very close to the one we actually do use. Having done that, you can then move to the feeds and speeds, and this is the critical bit that often students might mistype into. First of all, make sure you check here. The cutter only has 2 flutes. Okay, flutes are the names for the spiral shapes that kind of run around, and that means that if I look from this side there's one flute, and from the other side at the same point there's another flute, so we only have 2 flutes. The spindle speed we should be using is 23,000 revolutions per minute, so very, very, very fast. And the cutting speed that we would like to be running at is 3,500. Okay, you can change this manually, but we don't often do that, so it's just handy to set it up all correctly. So make sure everything else is matching, especially the clockwise option, and that's fine. Clicking OK, that would be your cutter selected. If you select that now and click OK, you'll now notice it appears on our cam setup, and having done everything there, if you click OK, you should notice that you've got 2 arrows and a line connecting them. At this point, if you select the simulate button and then make sure stock is selected, I like to click the top corner here, you can actually simulate exactly what we will tell from that program will tell the machine to do, and that is that 1, 2 drill cycles is exactly what the machine will do. And this is where you kind of suddenly realize how we're programming another machine, a robot, to do something. We're specifying enough information around it so it knows where it's going to be and what it's doing, and then we're telling it what we want it to do. In this situation, drilling, and we tell it where we want to drill and with what, and then you can do it. You can just keep clicking play. And the mastery thing, and the reason we use these in the car industry and all over the world, is because if you want to make the same thing again and again and again, all you need to do is keep clicking play. And that's kind of like why it's incredibly useful. Okay, well done for creating your first cycle and your first part of your manufacturing code. In the next one we'll be doing the next program. Thank you for listening.